Hello Gems! Welcome to another video of ACE series. In this video, we are going to discuss previous year BITSAT questions from the chapter of thermal properties of matter. Okay, so take a note over here that we have kept two chapters on hold. One is rotational motion and second is properties of fluids. Okay, we'll come to them super soon. If you're new to this channel, go check out the description box. Know more about ACE series. With that being said, I have nothing much to say. Let's begin for today. So let us begin the discussion with questions from the super easy category. So question 1, radiation emitted by a black body is directly proportional to, okay, the T stands here for temperature, okay. So you can see that radiation emitted by Stefan's law will be directly proportional to the fourth power of temperature, right? So option C is the correct choice. You can see that power radiated is directly proportional to the fourth power of temperature, right? For a given area, you can write that intensity is directly proportional to the fourth power of temperature, right? So this intensity represents number of radiation in itself, right? In a certain way, it represents the number of radiation. More the number of radiations, more is the intensity, right? So you can say that radiation emitted depends on the fourth power of temperature, is directly proportional to the fourth power of temperature. So a very easy peasy question from 2011. So question 1 done. Question 2, wavelength emitted by a body depends on. Does it depend on the nature of the body? Yes, it does depend on the nature, right? Different bodies emit different types of wavelength, okay? Does it depend on area? We'll come to that. Does it depend on temperature? Yes, Wien's displacement law. You remember that it's inversely proportional to area. So two of them are correct, which means all of them are correct because your paper is single correct. Big brain, okay? So anyways, coming to area, area of surface, how does it depend on area? So let's just visualize this. Suppose you increase the area of the body. Now absorption will increase, right? It will, the number of incident rays on it will increase. So it will absorb more amount of radiations, right? So by Kirchhoff's law, a good absorber is a good emitter. So it will emit more radiation, right? So it will emit more radiation. So that influences the emission as well. So area influences the emission. So wavelength emitted will also depend on area in some way. Okay, so all of the above is the correct choice. Over to the next set of questions. Question 3 and 4 over here, these are now from the easy category or the formula based category. In question 3, you have a rod of 1 meter. Its area of cross section is also given. Heat flow rate or the rate of flow of heat through the rod is given. The thermal conductivity of the material of the rod is also given. You are supposed to find the temperature change. There is some temperature change, right? That's why the heat is flowing. So you are supposed to find the temperature change across the two ends of the rod. Okay, quite a simple question because it is formula based. What is the formula? H equals Ka delta T by L, right? Ka delta T by L. I hope you know what each of this means. H will be the rate of flow of heat, right? So that will be 6000. K is our this thing, thermal conductivity, into area 0.75. I can write it as 3 by 4, right? Delta T, we need to find that, divided by L, length. What is the length? 1. Okay, nice. So 2 3s are 6, cancels with that, 10, and that will be 40, right? 40 degrees Celsius will be the temperature change. Again, question 4 is just a birthday twin of this, born in 2007. Okay, you can see the same data being given here. They just used a new term saying heat flux. Okay, so I'm just going to substitute the formula here anyways. Okay, so 4000 will be equal to, it's the same question. Okay, so 4000 equals K A will be, now we have to place it in meters, right? So 100 into 10 to the power minus 4 into Ka delta T, which we want to find, divided by L, which is 10 centimeters, 10 into 10 to the power minus 2. Okay, so we can cancel this, 1 2 1 2, 4 cancels this 10 times. Okay, this and this will get cancelled, 10 cancels 10. So what are you left with? you will be left with 10 to the power, this is 10 to the power minus 4 and this is 10 to the power minus 2. So you will be left with 10 to the power minus 2. Okay, I hope this is not untidy. So the temperature delta T will be 1 upon 10 to the power minus 2. Okay, just taking this to the other side, 1 upon 10 to the power minus 2 or 10 to the power plus 2, which will be 100. Option C is the correct choice. Okay, just similar question again appeared in 2007. Okay, so let's move to the next set of questions. Question 5 again from easy category, this time from 2013. Okay, so in this question you have a star, I mean you don't have a star, there is a star of radius r. Okay, it's a nice sphere of radius r. It is given that the star is a black body. Now in this question it was given that this star is a black body. Even if it's not mentioned in the question that a star is a black body, you are supposed to consider it as a black body. As far as your syllabus is concerned, we treat all stars as black body. Okay, anyways, an extra point. So you are supposed to find the temperature of this star. It is also given that rate of energy production is Q. Okay, so the approach is quite simple, right? We are going to use Stefan's law. First of all, tell me what is this rate of energy? What is this Q? Is it heat? No, it is not heat. If you see, it is rate of energy. So it is power. Okay, it is not heat, it is power. So let's apply Stefan's law now. The question is straightforward, formula based. So power Q will be sigma A T to the power 4. Okay, so I need not write that E now because it is a black body. E value is 1 for a black body. Okay, so from here we'll get Q by sigma into A. A will be nothing but the surface area of this sphere, right? For sphere, this area will be the surface area. So that will be 4 pi radius square, which is r square, is equal to T to the power 4. And we'll now take power 1/4 on both the sides. So that will give us option D as the correct choice, right? Q by 4 pi r square sigma whole raised to 1/4. Since we are going to take power 1/4 on both the sides. Okay, so option D is the correct choice. An easy peasy question from 2013. Let's increase the level now. Let's go to the easy moderate category questions. Okay, the favorite of your BITSAT. Yeah, let's go to them. Question 6, the first question from easy moderate category. Okay, so this was asked in 2017. So in this question we have a black body whose initial temperature is 300 kelvins. We are going to increase its temperature till it finally reaches 900 kelvins. So you are supposed to find the increase in the energy of the radiation. What is the increase in the energy of the radiation? By how much does the energy of the radiation increases? Okay, again a straightforward questions because you are going to use Stefan's law, right? Actually you can do it orally. You can see that temperature increases 3 times, right? The final temperature is 3 times the initial temperature. 300 3s are 900, right? So energy will be directly proportional to the 4th power of temperature. You can say that. So since the temperature increased 3 times, the energy will become 3 to the power 4, right? It's directly proportional to the 4th power of temperature. So 3 to the power 4. So the answer should be 81, right? Let's do it the standard way if you didn't get this approach. So E initial, the initial energy by final energy will be temperature, initial temperature by final temperature whole raised to 4, right? So you have to find final energy in terms of initial energy. Okay, so that is the way you are going to do it. So initial temperature 300, so 300 by 900, so that will be 1 by 3, right? 300 by 900, that will be 1 by 3 whole to the power 4. So you can see that the final energy, as I said, is 3 to the power 4 of the initial energy. Okay, so you can see that final energy is 81 times the initial energy. It has increased 81 times. So 81 is the correct choice. Again, a direct application of Stefan's law. Over to the next question. Question 7 from 2008. In this question, you are given temperature of a body A, temperature of a body B, temperature of the surrounding is given as well. Okay, so you are supposed to find the ratio of the power radiated by A to power radiated by B. Okay, again a similar question to the previous one. Here there is just a minute difference, that temperature of the surrounding is given. Okay, so again we are going to use Stefan's law, right? So power radiated will be directly proportional to T to the power 4 minus temperature of the surrounding to the power 4. In the previous case, the temperature of the surrounding was not given. We didn't take that into consideration. Now it is given, so we have to account for it. Okay, so Stefan's law is now updated. Okay, you can say that. So power is directly proportional to temperature of body raised to power 4 minus temperature of surrounding raised to power 4. Okay, so in the previous question we also used energy is directly proportional to T to the power 4. Okay, actually a wrong notion. For a given time, energy is directly proportional to T to the power 4. Okay, so that was something assumed in the question 6. Okay, anyways, coming back to this question, power radiated by A divided by power radiated by B will be TA to the power 4. So temperature of A, now you have to convert this in kelvins. Okay, so convert this in kelvins at 273, so that will be 600, right? 600 to the power 4 minus temperature of surrounding, this will be 273, so 300 to the power 4 minus, this will be 500, 100 less, right? So 500 to the power 4 minus again 300 to the power 4. Okay, so go ahead and solve this. I'm not going to solve this, it's very tedious. The answer that you will get is, I guess, 2:1. Okay, do verify it. So the answer will be 2:1. Go ahead and solve this. Only the calculation part is remaining, right? Let's move to the next question now. Question 8 over here, I'll just explain you what this question wants to say. So in this question, you have a rod of length 50 centimeters, cross-sectional area 0.4 centimeter square. You are supposed to find the force that should be applied to this rod so that it produces an extension of delta L. Okay, when you apply force, there will be some deformation, right? Extension. So this delta L, the case is that this delta L should be equal to the extension produced when the same material is heated by 10 degrees Celsius. Okay, so thermal expansion. You'll know that things in general expand on heating, right? So there will be an extension in its length when its temperature is increased by 10 degrees. So you have to equate this extension, the one produced by increase in the temperature, to the one which is produced due to the force. Okay, that is the only idea. You have to equate the extension produced, the extension or expansion produced by the temperature change to the extension produced by the force. Okay, so delta L will be equal to L alpha delta T, right? Due to thermal expansion, it will be L alpha delta T. First of all, let's write it for Young's modulus. Young's modulus is given as FL by A delta L. You remember the song from previous class, right? From here, we can write delta L as FL by Y. FL by YA. So this delta L is L alpha delta T. Okay, now we have to just equate them. Equate this extension to this one, right? So L alpha delta T equals FL by YA. So this L and this L will get cancelled. You are supposed to find the force, so that will be alpha into, this is delta T, this is not A, this is delta T, right? So into Y into A, so that will be the force. So alpha is 10 to the power minus 5, temperature change is 10, right? Y, Young's modulus, 2 into 10 to the power 11, area is 0.4 into 10 to the power minus 4, right? Converting centimeter to meter square. Okay, so that will give you 2 into this 0.4, 0.8, 0.8 and this 10, so that will give you 8, right? So 8 and 8 into, you can see that it will be 8 into 10 to the power 11 minus 5 minus 9, right? 5 and 4 minus 9. Okay, so that will be 8 into 10 to the power 2, that will be 800. 800 is the correct answer. Okay, over to the next question. I hope this is clear. You can take a screenshot, you can pause and note. The notes are also available on the website too. Okay, so over to the next question. Question 9 over here, it's from 2015. It's based on Newton's laws of cooling, right? So finally, something different from Stefan's law, finally, okay? So in this question, we have a body initially at a temperature of 80 degrees Celsius. It cools down to 60 degrees Celsius. It takes 10 minutes for that, okay? From 80 to 60, it takes 10 minutes. The temperature of the surrounding is given as 30 degrees Celsius. You are supposed to find the temperature of the body in next 10 minutes, the 10 minutes after this, or 20 minutes from the initial condition. Okay, so let's just apply Newton's law. It's quite a simple question. Okay, so dt, the rate of fall of temperature, is equal to k times the difference in the temperature of body and temperature of surrounding, right? So it will be tb minus ts. Okay, so dt, the change in temperature, 80 minus 60, that is 20. This dt is time taken, that is 10 minutes. Okay, this is k. Your temperature of the body, now you can see the temperature of the body is changing. Which value will you place? Average, right? We'll take the average. We make an assumption over here, we take the average. So average of 80 and 60, that will be 70, right? No need to calculate. Minus temperature of surrounding, 30. Okay, so this and this will get cancelled. 2 equals k into 40. So k value, you can get it from here. K value is 1 by 20, right? K value is 1 by 20. Now let's apply the Newton's law in the second scenario. Okay, the next 10 minutes. So you can see that the temperature of the body is unknown. We have to find it for the next 10 minutes. So dt, what is the change in temperature? In this case, it will be change from, now the body begins at 60 degrees Celsius, right? In the next 10 minutes, the body will begin at 60 degrees Celsius and it will go to some TB, which we have to find. So the temperature change is 60 minus TB, right? It begins at 60, it goes to TB. Okay, so 60 minus TB, that is the temperature change. It took 10 minutes for that, equal to k. K value we already know, 1 by 20 into difference. Now we have to write it this way, clean, tidy. So 1 by 20, this is the k value, into now temperature of the body. Now the temperature of the body, we have to take the average, right? So that will be 60 plus TB by 2 minus temperature of the surrounding, that is 30, right? So let's just solve it now. This and this can get cancelled. So 60 minus TB, 60 minus TB equals, you can take the LCM, this will be minus 60, and this 60 will get cancelled, right? So upon 4, 2 2s are 4, okay, and this 60 got cancelled, and TB value, TB over here, so we have to find TB. So 60 into 4, 6 4s are 24, 240, and that will be minus 4 TB. Over to the next side, 5 TB, right? Just solving, okay. So 5 TB equals 240, which means temperature of the body is 240 by 5. 5 4s are 20 and 4, so yeah, 5 8s are, right? So 48. 48 will be the correct answer. Okay, so direct application of Newton's laws 2 times. I hope the question is clear. We'll practice one more of this sort. Question 10 will be one more based on Newton's law of motion. Okay, so over to question 10. Question 10, as I said, again, it's based on Newton's law of cooling. Okay, it was asked in 2010. So in this question, you have a body initially at a temperature of 62 degrees Celsius. It goes to 50 degrees Celsius in 10 minutes. Now in the next 10 minutes, it goes from 50 degrees Celsius to 42 degrees Celsius. Okay, you are supposed to find the temperature of the surrounding. Actually, Newton's law of cooling type questions has this very standard approach. You write the Newton's law of cooling 2 times and then you do some wise manipulation and you get the answer. Okay, let's do it over here. So what is the formula? The rate of fall of temperature is equal to K times the difference of the temperature of body minus temperature of surrounding. Okay, difference of the temperature of body and temperature of surrounding. Let's write it in the first case. This is our first case and this will be our second case. So in first case, the fall in temperature is 12 degrees, right? Time taken is 10, and here we'll have K into temperature of the body. So we'll take the average, right? So 62 plus 50, 50, 50. So that will be 112 divided by 2. That will be 5 and 6, 56. That is the average. Add them to add the 2 and divide by 2, right? And minus temperature of surrounding, which we want to find. Let's write the equation in the second case. The fall in temperature is 8 degrees now. Time taken is 10 minutes into K into the average over here. So 40, that will be 92, right? 40, 50, 90, 92, 92 divided by 2, 46. Yeah. So 46 minus the temperature of the surrounding. What you will do, you'll just take the ratio of this two. Okay. So 10 cancels with 10 and you'll be left with 12 by 8. I'm taking the ratio, and K cancels with K, right? 10 cancels with 10, 12 by 8, K cancels with K, and here you'll get 56 minus theta S divided by 46 minus theta S. Cancel this by 4, 4 3s are 12, 4 2s are 8. Okay, so it goes on the other side, 56, 2 into 56 into theta S. Okay, and here it will be 3 into 46 minus theta S. So here 46 into 3, 6 3s are 18, 3 4s are 12, 13, 138 minus 3 theta S. This will be 112, right? And minus 2 theta S. So that will give you theta S to be equal to, this will be 3 theta S minus 2 theta S. 3 theta S minus 2 theta S, that will be 138 minus 112. Okay, taking this to the other side. So 6 and here you'll get 2. So 26 degrees Celsius is the correct choice. Okay, so a very standard approach of doing this type of question. Write the equation for the two times Newton's law of cooling. You write it for 2 times. Either take the ratio or manipulate it in wise way. You'll reach your answer. Okay, so this type of questions are actually very easy. Let's move to question 11 now. Question 11, in this question we have 4 rods. Each of these rods are made up of the same material but they differ in dimensions. You can see their dimensions over here. Each of the rods with their respective dimensions over here. R represents radius, L represents length. Okay, so each of these rods are maintained at a temperature difference of delta T. Their both ends are maintained at a temperature difference of delta T. You are supposed to find the rod which conducts more heat. Okay, find a rod among them which conducts more heat. You can give it a try. You can pause and try. I'll do it in 3, 2, 1. Okay, so the concept, the idea that we are going to use over here is that R thermal should be minimum, right? For a rod which conducts more heat, thermal resistance will be the minimum, right? So that's why it is able to conduct more heat. So what is R thermal? How is R thermal given? R thermal is L by Ka, right? So since each of this rod is made up of the same material, you can say that R thermal is directly proportional to L by K. Right, K value is same for all of the rods. Okay, so since we want to make this R thermal value, we want to look for a rod which has the minimum value of R thermal. Okay, so we want minimum value of R thermal. So in this case, what do we want? L should be minimum, right? For R thermal to be minimum, L should be minimum, and A should be, since it's in the denominator, A should be maximum, right? I'm just going to compare among the options, right? So that's why I'm saying minimum and maximum. Okay. Yeah. So A maximum means radius should be maximum. Okay. Direct relation between the two. So A maximum just means radius maximum. Okay. So let's compare between the options. Actually, the thing that you can do is substitute each of this value, find R thermal for each of this A, B, C, D, and then find which R thermal has the minimum value. Is it A, B, C, D? And that R thermal which has the minimum value will be your correct choice. Okay, whatever dimensions give you the minimum value for R thermal, that will be your correct choice. But I'm going to use a little bit of brain now. Okay, I know that I want L value to be minimum. L value to be minimum. You can see it in two cases, one this and one over here, and A value to be maximum, which implies R value to be maximum, 2R, right, and R over here. So this option B satisfies both the conditions, right? L value minimum, R value maximum. So this is the rod which is going to conduct the most heat. Okay, you can also watch it the other way, looking at the heat current, right? The rate of flow of heat, H is Ka by delta T, Ka delta T by L. Okay, so H is directly proportional to A by L. Okay, so here in this case you want to increase heat current, right? You want to increase the rate of flow of heat so that more heat is conducted. Okay, so this is another way of looking at it. Okay, so here in this case you want to increase area and decrease length. Okay, so similar condition you can see over here. You can also watch it this way. The answer is option B anyways. Okay, let's move to the next question now. Question 12 over here. In this question, you are supposed to find the required heat for converting 40 grams of ice, which is at minus 20 degrees Celsius, to 40 grams of water at plus 20 degrees Celsius. Okay, you are provided the following details: specific capacity of water, the latent heat of ice, specific heat capacity of ice. Okay, so if you see, this is not just a step, right? It's a process happening over there. So we'll break it into series of steps. So first step, let's take 40 grams of ice, which is at minus 20 degrees Celsius. First, we'll convert it to 40 grams of ice. Okay, still ice, but now at 0 degrees Celsius. Okay, so we increase the temperature by 20 degrees Celsius, of course. And then the second step is to convert it to water. Okay, make 40 grams of water at 0 degrees Celsius. Okay, so you can see latent heat involved over there. Anyways, the final step will be heating this water further so that its temperature increases to 20. Okay, so 40 grams of water now at 20 degree Celsius. Okay, so these are the four steps. These are the three steps, 1, 2, 3. Okay, so we are going to add the heat in each of this step. Okay, so for this step, you can see that the heat required will be M specific heat of ice into delta T. Delta T is 20. Okay, so M mass is 40 ms. Now S for ice, right? Ice is under consideration, so that will be 2100 ms and delta T, that is 20. Now remember that this is 40 grams. Okay, and it's not in kgs. Now step 2, this is step 1, Q1, Q2. Now Q2 will be now you're converting ice to water at the same temperature, right? Now this is latent heat, right? So M into L, M is 40 again grams, and L is the latent heat, which is 336 into 10 to the power 3. Finally Q3 will be converting this to this, right? So ms delta T again, so M is again 40, S is specific heat capacity of water. Now since water is under consideration, so water, that will be 4200 into ms delta T. Again the temperature changes 20. Okay, so we have to solve this. So what I'll do, I'll take that 40 common. Now since it was grams, I'll multiply it by 10 to the power minus 3, okay, to make it kgs. So we are left with, here we'll be left with 3 zeros, right? So 10 to the power 3, 21 to the 42, plus here we'll have 336, 40 is taken out common, to 10 to the power 3, plus here 40 has gone out, so this 3 zeros again into 10 to the power 3, and here 42 to are 84. Okay, so this 10 to the power 3 can come out and will get cancelled with this one. Okay, I can just cancel it out from everywhere. Okay, so we just have to add this 336 plus 84 plus 42. Okay, 10, 12. So 8, 8, 4, 12, 12, 3, 15, 16. Okay, 16 and one more. So that is 462, 462 into 40, right? So this is 462 into 40. So 462 into 4, 8, 6 4s are 24, carry 2, 4 4s are 16, 17, 18, 1840. Yeah, it was into 40, right? So 18480, 18480. Okay, quite a simple question. We just had to break it into steps and add the heat at each step, right? So over to the next question now. You can note this down. So question 13 over here, now you can note that the level has increased. It's a moderate level question now, okay? So includes a bit of thought process. Anyways, let's come to the question. In this question, you have 1 kg ice at 0 degrees Celsius and 1 kg water at 80 degrees Celsius. You just mix the two. What is the temperature of the mixture? Okay, here are some of the details that you'll need. Okay, so seems quite a straightforward question, right? So let's just do it. Okay, so the heat, the idea that we are going to use over here is that the heat from the water, since the water is at higher temperature and ice is at lower temperature, heat from water will flow to the ice, right? So heat from water will be used for two purposes. One is to melt the ice, it will melt the ice, and second is to raise the temperature, right? So first of all, it will melt the ice, and then it will raise the temperature of the mixture. Okay, so heat released by water will be mc delta T. Okay, mc delta T, so ms delta T. So mass of water is 1 kg, 1 into m into s. S is specific heat of water, 4200, into delta T. Delta T will be change in temperature. Now the change in temperature will be 80 minus temperature of the mixture, right? Finally they reach, finally the mixture is at the temperature this T mix, right? So yeah, so the temperature change in case of water will be 80, initially 80 minus temperature of the mixture. Okay, and then this will be equal to, now this heat is used for melting ice. So latent heat of ice, m into L. So m is 1, mass of ice is 1, and latent heat is 336 into 10 to the power 3. Okay, so first of all it's used in melting of ice, and then it's used in raising the temperature. Okay, it will raise the temperature of this melted ice. Okay, the ice was at 0 degrees Celsius, now it has become water at 0 degree Celsius. Now it will increase the temperature to T mix, right? The ice was initially at 0 degrees Celsius. By giving this amount of heat, the latent heat, it has been converted to water at 0 degrees Celsius. Now the second job is to raise temperature till T mix, right? So that's how they reach the same temperature, right? Obviously, logic. Okay, so yeah, so that will be ms delta T. ms, again specific heat of water, since ice is converted to water now. Okay, so ms and delta T, change in temperature from 0, basically change, okay, difference. So from 0 to T mix, right? So the change is T mix, right? Changes T mix. Now let's just solve this. This will be 4042 into 8, 42 into 8, 8 2s are 16, 8 4s are 32, 33, so 33 and 3 zeros, 336 into 10 to the power 3 minus 4, 200 into temperature of mix equals 336. Can you see something fishy over here? Not my handwriting, but yeah, 4200 temperature of mix. Okay, so you can see that this and this will get cancelled. 336 into 10 power 3, 336 into 10 power 3. So you'll be left with 8400 T mix. Add this and that equal to 0, which means temperature of the mixture is 0. So is this the correct answer? Some of you might have notions that, see, we begin with these two things, one which is at temperature 0 degrees Celsius, other at 80 degrees Celsius, right? And some of you will have this notion that now since we mix this two, the temperature of the mixture should be somewhere in between the two, and we are getting the answer as 0 degrees Celsius. So my question to you, is 0 degrees Celsius the correct answer? Right? So this is something that you will comment in the comment section. Okay, so you are supposed to comment about this and hold one opinion. Is the answer 0 or not? If 0, justify why it is 0. If it is not 0, which is the answer, and justify why is it the answer. Okay, so that is a homework for you. You will give it a try. Okay, you'll think about this. Okay, over to the next question. That will be your homework questions, and then maybe we'll wrap up with the class. Okay, so this was a good one. You are supposed to, don't forget to comment. Okay, and the correct answer, of course, will receive a heart from me. Okay, so over to the last question for today. So question 14 over here, it is your homework question. It is also a moderate category question. It appeared in 2016 BITSAT. So do give this question a humble try. You can pause this video now and take a screenshot. Okay, after solving, the answer that you should get is this, option D, 8:25. Okay, so that's all for today. I hope you enjoyed it. I'll see you soon in the next class. Don't forget to follow the word series which is going on my Instagram. That will help you boost your score in the English section of your paper. Do some charity, links in the description. Also share this video with somebody and help them in their BITSAT preparation. Smash like, subscribe, keep enjoying physics.